Hi, thank you for joining us for this session. I'm glad to be here with you today. In this session, we will share our experiences regarding automotive user experience and proof of concept development using Flutter. Before we go any further, please allow me to introduce speakers of this session. My name is Woojin Han, and I'm a technology director of DreamAce. We also have Dr. Jung, and he is a professor of Seoul Women's University and design center leader of DreamAce. DreamAce joined AGL in 2017, and we are specialized in developing and customizing infotainment software platform based on AGL and virtualization technologies. And we've been widening our perspectives ranging from embedded technology to user experience design. We've got some interesting topics to show you during the session. Dr. Jung will share his point of view about automotive user experience. And then we will share our proof of concept development named Automotive Flutter Widgets. Frankly speaking, when it comes to Flutter, we were just beginners a few months ago, but we've been working hard on this and we've got some information to share. If you have any questions, feel free to ask by using text chatting system during the speech. Our members are ready to answer your questions, so let's get started. We are going to start off by talking about motivations regarding automotive Flutter widgets for the interior cockpit system. As we all know, the interior cockpit system has many advantages ranging from holistic user experiences in the car to cost saving. And especially, the number of screens in the vehicle is increasing and the size of screens is getting larger and larger. So it is very important to handle these screens effectively. We think that container-based virtualization technology could be one of the good way to meet today's needs and interests. Last year, in AGL 2020, we shared our experiences regarding interior cockpit system based on AGL and multiple containers. On the other hand, we've had chances to meet potential clients who are considering Android Automotive OS-based interior cockpit system. We've been finding a way to build this system as requested. In this situation, as a startup company, software reusability is one of the most important issues to handle. How can we enhance the efficiency and effectiveness of application development? We think that Flutter can be a strong candidate to work out this situation. Flutter is an open source UI framework by Google for building natively compiled multi-platform applications from a single code base. Currently, there are more than 200,000 applications were developed by using Flutter. These applications are made for mobile or desktop environments. By the way, it seems that Flutter is about to enter the automotive industry. Recently, Toyota announced that they are taking a new approach to building a next-generation vehicle infotainment system powered by Flutter. Also, Flutter has been one of the key issues of the IVI expert group of AGL, and Toyota Connected North America released the IVI home screen and Flutter engine package. In this session, we will introduce the idea about automotive-grade usability for future vehicle UX, and then proof of concept development experience to implement this idea by using Flutter will be shared. So let me pass my mic to our UX expert, Dr. Jung.
Okay, thank you, Mr. Han. Hi, I'm Jung. Today, I'm going to tell you about automotive-grade usability. So, before talking about automotive-grade usability, I would like to take a look at the definition of usability. So, according to ISO, usability means extent to which a system, product, or services can be used by specified users to achieve specified goals with effectiveness, efficiency, and satisfaction in specified context of use. Among the three components of usability defined by ISO, effectiveness is about accuracy and completeness with which users achieve specified goals. And efficiency indicates resources used in relation to the result achieved. Regarding satisfaction, its extent to which the user's physical, cognitive, and emotional responses that result from the use of a system, product, or service meet the user's needs and expectations. And the questions in the gray area gray color next to the definition of each component They are used to determine whether a product or system has a good usability. So the concept of usability has been used especially for web or mobile user experience design. Please next to the page. So let me show a mobile UX example with good usability. Samsung took advantage of this concept of usability to design their smartphones. The image you can see in the lower left show the area where our thumbs naturally touch when we hold the smartphone in one hand. We call this the thumb zone. Based on this, designers at Samsung divided the screen with two areas. One is called interaction area, where interaction components are placed so that users can easily touch them. And the other one is viewing area with only information that does not require interaction. With this design, the users not only can achieve their desired goals easily and quickly, but also have visually satisfying experiences. Then with the concept of usability, which is widely used for web or mobile UX design, be applied to the automotive UX as it is? Since mobile phone and in-vehicle infotainment has many differences in the context in which they are used, it is difficult to apply the existing components of usability to automotive UX. For example, a mobile can be used in diverse situations, such as walking in the streets or lying in the bed. However, IBI can only be used in a car. So also, while the mobile screen doesn't have a huge influences on the surroundings, the graphic style of IBI plays an important role for an interior of vehicle. The reverse case is similar as well. While the external environment does not significantly affect the use of mobile phone, the driving condition greatly affect the use of the IBI. And most importantly, the use of mobile phone does not influence on the user's safety, but the interaction with the IBI has a large impact on safety. Comprehensively, a mobile phone is a standalone device, but the IVI is closely related to the environment and situation of the vehicle. So as you've seen earlier, mobile and automotive UX has a big differences depending on the using situation, and it is necessary to redefine usability for automotive UX. So we called it as automotive grade usability. For developing automotive grade usability, we conducted several studies to deeply understand the nature of automotive UX and IVI. Through the case study making user journey map and observing drivers' behaviors, we could draw automotive grade usability and its related design principles. So these are 4 components of automotive grade usability derived through the process that I explained earlier. We have added safety, which is an important value of automotive UX, to the existing components of usability. And also we redefine the questions for automotive grade usability as you can see in the slide. By asking these questions, we can judge the level of automotive grade usability. Developing automotive grade usability like this is important for creating good automotive UX and HMI. If we utilize AAOS, we can achieve a certain level of usability, but customization is possibly only within the AAOS framework. So there is a limitation that cannot escape your Google UX. However, understanding these underlying fundamentals and the values of automotive UX gives us a lot more freedom to design good HMIs. By taking advantage of this automotive grade usability, we can generated 4 HMI design principles: recommending actions, responding to vehicle movement, using part of the screen, and ensuring the real environment are closely linked to the 4 components of automotive grade usability as seen on the screen. And its principle will be explained with Dreamase IVI examples in the following slides. The first one is about recommending actions, and it refers to the the IVI suggests menus or functions that the users are most likely to do in the situation. The part marked with the yellow box on the IVI is the screen that appears when the user just gets into the car. On the left, IVI recommends places that the user most likely to find, and the lower left corner, the recently used menus are shown. These recommendations increase the effectiveness by helping users easily access to the menus and achieve their desired goals. In addition, it provides emotional satisfaction by making them feel that IVI understands their needs. The second one, responding to vehicle movement, means that a certain function is performed automatically in response to the vehicle's movement. For example, when the user starts a car and starts moving, place recommendation menus are replaced with the map screen. This is the same concept as it is the user puts in reverse gear and the rear camera is activated. By applying this principle to the IVI, the efficiency increases because the user does not have to do all the actions by him or herself. In addition, there will be less distraction for driving. Thirdly, using part of the screen refers to the using only a part of the screen of IVI rather than using the entire screen when using some functions. If the full screen continues to switch every time a function is used, it is difficult for users to understand the information structure easily and the system feels complicated, and the effectiveness of the using system decreases. Unlike mobile, IVI has a larger screen, so it can show many functions using only a portion of the screen. In this way, users feel that the structure of the information is much simpler. In addition, it is helpful for safe driving because it does not require much attention from the users when changing the screen. Lastly, showing the real environment means showing the information in the IVI consistent with the real environment of the vehicle. By doing so, the user has the advantage of being able to understand the function more intuitively. Also, it gives higher emotional satisfaction in terms of visual aspects than giving infotainment consisting of only icons and text. So far, we have shown automotive-grade usability, design principles, and application examples of DMS IVI. This concept still needs to be further advanced, and it is also necessary to apply and verify it in practice. We will continue with this part and show it as further contents. Thank you.
Now let me go on to our proof of concept development status. The first thing I'd like to show is development environment. We've implemented a compact version of interior cockpit system, which includes central information display and passenger display. Home screen has been implemented by our Automotive Flutter Widget components on top of the IVI home screen, which was provided by Toyota Connected North America. As far as I know, this Flutter framework is a transitional process to migrate Flutter into AGL UCB in the near future. It seems that this framework supports x86 environment, so we composed Ubuntu desktop environment. At the time we began to pay attention to Flutter, we searched Flutter embedder that supports AGL. Basically, Flutter supports cross-platform operation, and to do so, Flutter embedder which can be interacted with specific operating system should be supported. Unlike the Android or iOS, we thought that porting Flutter to the embedded Linux system is in its early stage. There are three kinds of options we've tested. While we tested Sony's and Joel's work, we found out that IVI home screen was introduced to AGL IVI EG members. We thought that this work will be adapted into AGL UCB, so we decided to use this. This project has a couple of different meanings for us. Since Flutter has many advantages to develop applications, we thought that we need to be accustomed to Flutter development. By doing so, we wanted to understand how IVI expert group tries to adapt Flutter into AGL and we hope that we can give a contribution to Flutter-related activities in the IVA expert group someday. Also, this project is a stepping stone for developing automotive-grade usability. We have a plan to use Flutter to implement system user interface on top of Azure systems. And since the internal cockpit system is one of the major trends of modern vehicles, we wanted to understand how Flutter can be used for multi-display environment. Finally, we thought that it will be a good chance for exploring multi-platform adaptation issues. To implement home screen that supports multiple display, we've considered two Flutter widget architectures. First one is divided screen model. This model is a general approach of current integrated cockpit systems. In order to implement multi-OS systems, hypervisor or container solutions can be used to isolate features of each display. We also think that this model has many advantages, but it is a burdensome approach for a quick proof of concept development. For example, data communication method needs to be implemented to support multi-screen features such as end-screen animation or multi-screen control. The other one is splitted screen model. This model is a unique approach to implement integrated cockpit system. Although it has a couple of points that needs to be modified to adapt into a real vehicle environment, it provides a convenient way to test various kinds of user experiences with Flutter. Both CID and PD screen are included in single home screen. To do so, we modified the settings of Wayland Compositor to avoid full screen issues. With this model, we could minimize additional development issue compared to the divided screen model. This slide shows general widget tree structure. Both display screen widget for CID and PD are child widgets of a home screen widget. Since these two widgets are under the umbrella of the home screen widget, communication between two screens is very convenient. As I mentioned earlier, this split screen model may not be the best solution to implement integrated cockpit systems, but this model is a good way to simulate Flutter widget features in case of adapting Flutter into multi-screen environments. Since service screen widget is responsible for operating services which are composed of Flutter widgets, this widget is a parent widget of service layout widget. So running multiple Flutter applications in single screen was possible. In this project, several applications such as navigation, media, core can be run, and interaction between two displays is implemented. When it comes to implementing navigation, we've tried to use Google Maps library, but because of platform dependency issues, we couldn't make it done. Navigation in this project is just Flutter applications, which plays pre-recorded GIF file. Now, before we go any further, let's take a look at demonstration. So did you enjoy our demo? I hope you can get some insight to apply Flutter to vehicle applications. Let's examine this in a little more detail. First, as mentioned earlier, we've implemented split screen model, which includes both CID home screen and PD home screen. So both display screen widget for CID and PD are the child widget of home screen widget. Since these two widgets are under the umbrella of home screen widget, communication between two screens is convenient. There are two types of applications which is made by Flutter can be operated in this home screen. Automotive service such as navigation, HVAC, seat, video player, phone are part of the home screen. These applications are not built as an independent applications, but merged as a source code level. The other type is third-party Flutter application. Although we merged source code of third-party application into home screen due to the limited time and resource, these applications such as gallery, as seen on this slide, operates well. Multiple applications can be operated in a single display by using service screen widget and service layout widget. On top of that, display screen widget is in charge of each split screen. Display screen widget includes bar screen widget and service screen widget. Bar screen widget can be enabled or disabled depending on the situation. Since service screen widget can be divided by service layout widgets, multiple applications can be displayed and operated in single display. Using part of the screen is essential in case of considering effectiveness and safety in the vehicle, as Dr. Jung said. To implement home screen overlay widget, we've customized the dialog widget of Flutter. This home screen overlay widget can be operated over the service screen widgets. Home screen overlay widget includes child widgets, which are responsible for detailed features of applications such as volume control, seat control, and HVAC control, etc. Also, animation effects can be adapted to express natural movement, so home screen overlay widget can be enabled or disabled smoothly. Under the current development environment, background application features cannot be controlled unless home screen overlay widget is disabled. As mentioned earlier, third-party Flutter application can be operated in our POC environment. Third-party Flutter application can be operated via service layout widget, which is a child widget of the service screen widget. Although we merged the source code of the third-party application into home screen due to the limited time and resource, third-party applications such as gallery as seen on this screen operates well. To maximize user experience in the car, we can find full screen animation examples which utilize multiple screens in the car. In this demo, we thought that it would be great if animation can be operated on top of two displays seamlessly. According to our widget tree, if we adapt animation effect into home screen widget, which includes both display screen widget of CID and display widget of PD, animation effect can be expressed on top of two displays. There are two types of animation effect. First, we implemented animation effect and adapted into home screen widget directly. The other one is that GIF animation player is running on top of the two displays. This slide shows sliding animation effect between two displays. First, size of navigation in CID enlarged to fit full screen. To do so, screen size can be controlled by adjusting service layout widget. After sensing the swipe events, thumbnail of navigation screen moves to the right, and then navigation screen moves to passenger display and operates this function. If we use divided screen model mentioned earlier, it will take more time to implement this scenario. As we know, communication between isolated displays needs additional efforts such as inter-process core or DRM management. In this demo, we focused on the Flutter widget operation on top of the multiple display configuration. Now let me go on to our plans. We have a plan to continue both user experience and automotive Flutter widget development. Since Flutter has been mainly targeted mobile applications, we think that UX design principle or philosophy is not perfectly matched with automotive grade usability. So we will enhance current design concept as introduced in this session and adopt Flutter to implement this design concept. On the other hand, we think that we need to go the extra mile to use Flutter quite freely. This POC environment was proceeded on Ubuntu desktop, but we need to migrate to Azure UCB environment to apply Flutter to commercial development. Also, binding to native code in Flutter is an important topic to consider. We think that we need to follow up Azure IVA expert group and application framework expert group regarding this. Enhancing multi-display architecture will be a future R&D topic. Although we introduced the splitted screen model in this session, we know that it is not the best approach to implement into the cockpit system. And since we are proceeding both AGR and AAOS development, cross-platform usability and code reusability should be taken into consideration. Finally, during the POC development, we thought that if native Flutter home screen can support the web view, content sourcing will be more effective and convenient. So thank you for your attention. Although Dreamers has not been attended Azure expert group activities, we have a plan to participate in some expert groups such as IVA production readiness expert group and virtualization expert group. I hope that we can keep discussing in Azure meetings. Thank you.